Sketch the graph of y equals 2x plus 5 multiplied by x minus 3 to the power of 3 on the set of axes provided. Clearly label any axial intercepts with their coordinates. So the first thing we can do is inspect this rule, and we can see that the 2x plus 5 is a linear factor, and that means that at the x-axis there'll be an intercept something like that. For the x minus 3l cubed, that indicates that there is going to be a stationary point of inflection on the x-axis. Next, what we want to do is find the x and y intercepts of this graph. So the y-intercept is going to occur when x is equal to 0. For our rule, we will have y is equal to, and we will have 2 times 0 plus 5 being multiplied by 0 minus 3 to the power of 3. Evaluating that, we find y is equal to, and 2 times 0 plus 5 is simply 5, and then negative 3 cubed is minus 27. And if you evaluate that, you find that 5 times negative 27 is negative 135. Therefore, we have a y-intercept at 0, minus 135. For the x-intercept, we let y equal 0. So for our rule, we're solving 0 is equal to, and it's 2x plus 5, and then x minus 3, all cubed. As this is in factorised form, we can use the null factor law, which says that 2x plus 5 could equal 0, or we could have x minus 3 equal to 0. Subtracting 5 from both sides of this equation gives 2x is equal to negative 5, and dividing both sides of the equation by 2 leaves us with x is equal to minus 5 divided by 2. For the second equation, we simply add 3 to both sides, and that will find x is equal to positive 3. Therefore, we have x-intercepts of minus 5 divided by 2, 0, and 3, 0. The last thing we need to check before we graph this is whether or not it is a positive or negative chordic. So if you were to expand these brackets, you'd find that the x to the power of 4 term has a positive coefficient, which means that this graph is going to look something like this. Now remember, we know that the shape is like this because it's a positive chordic, and we knew that there was going to be an x-intercept that cut the axes at negative 5 over 2, 0, and we knew that that part of the graph looked like that because it was a linear factor. Then we had the x-intercept over here, which was at 3, 0, and we knew that was going to be a stationary point of inflection because of this x minus 3 cubed repeated factor. And then all we had to do was draw a general shape that included those two key features. We also have to label this y-intercept, which we found to be 0, negative 135. And that's the graph of this chordic equation. On the next slide, we've just got a computer to generate the same graph. And as you can see, all the same key features are there. And we've also got the computer to put in the coordinates of the local minimum stationary point.